Listen, ladies and gentlemen. So he's going to introduce chapter 6 for you, all about Newton's third law, action and reaction. All right. So, you know, when new teachers come into teaching, right, they have to take a lot of courses, and they do a lot of additional training, and that's part of what he's going to do right now. All teachers have to do that. So, anyway, Mr. Mon, it's your classroom. Now, ladies and gentlemen, give him due respect. We're quiet and we're listening. All right? Okay. All right.
Good afternoon. How is everybody?
Great.
Good. I gave you a handout. It summarizes Newton's three laws of motion. As Mr. Sunsley said, today we're going to learn about Newton's third law of motion. Just take 2 minutes and read Newton's laws of motion, Newton's first law of motion, and Newton's second law of motion. It should be a summary for most of you.
Extras.
Okay, this is a review, right? Okay, good. So just let me ask you a few review questions. What is a force? Push or pull? Good. A force is a vector, so it has magnitude and direction. What's the meaning of magnitude? A number. Very good. I'm going to tell you a very quick story. It was very funny. One of the first times I taught physics, I asked my students, what's a vector? And a student raised his hand very confidently. He says, a vector has magnitude and direction. And I said, very good. What's the meaning of magnitude? He just sat there. He had no idea what magnitude was. So I said, it's good to use big words, but make sure you know what they mean. So it's good. You know that magnitude means number. Very good. Somebody tell me the name of Newton's first law of motion. The law of? You said it? Yeah. Newton's first law of motion. It's a law of? Good. It's the law of inertia. What's the meaning of inertia? Good. So objects don't want to change what they're doing unless? Good. Speak louder so we could all hear your voice.
The sum of external forces and the object does not equal moving.
Good. Does anybody know the name of Newton's second law of motion? The law of?
Acceleration.
Good. What is acceleration? Acceleration is when three things happen. When you pick up speed or decrease or change direction. Very good. So when you speed up, slow down, change direction. What's the equation in Newton's second law of motion? F equals m times a. What comes right before F? There's something right before F. Not A. F equals ma. You said it. F equals ma. Yeah, what's that E? You guys see that funky E? What's that? That's a Greek letter. You are correct. It's sigma. You guys know what sigma stands for? It means total. So add up all the forces, and that's equal to the mass times acceleration of the object. So if you're just looking at the x direction, the total forces in the x direction equals the mass times the acceleration of the object in the x direction. Okay. Now let's learn about Newton's third law of motion. Newton's third law of motion is called the law of action and reaction. You guys know the meaning of action? What's the meaning of action? Movement, okay. Action is when you do something, right? Good. Action is when you do something. What is the meaning of reaction?
What happens?
Say that louder. Yeah, when you act to something. So action is when you do something, reaction is when you react to something. Very good. So somebody read with a very loud voice the first sentence below Newton's third law of motion. Can I get a volunteer?
Newton's third law of motion always requires one force and two objects.
Beautiful. So how many forces?
One.
One. How many objects? Good. Someone read the second? Yes.
If object A puts a force on object B, then object B puts a force of the same magnitude/number, but in the opposite direction on object A.
Okay. Does that sound like something that makes sense, or is that like Russian?
Russian.
Russian? Okay, good. So let me give you an example. I push the seat down. What does the seat do to me? Pushes me up. Very good.
Third law.
It was opposite in direction, right? I said I push the seat down, the seat pushes me up. How many objects did we have? Two, good. I push the wall to the left. The wall, you to the right. With the same force?
Yeah.
Okay, good, good. So my fist punches your face. Okay? What's the reaction? His face punches my fist. Isn't that weird? You never thought about that. Okay, what if we're both driving and I hit your car? You know, you call the police, you call your insurance company that says, no, his car hit my car. Who's right? We're both right. Isn't that weird? Yeah. Okay, good. So, that means you're thinking. Good. Look at the equation on the bottom. It says force of object A on object B is equal to minus the force of object B on object A. So the left-hand side, there's a what sign? Positive sign or negative sign? Positive sign. And on the right side, is there a positive sign or negative sign? Negative. So these forces are equal in magnitude and opposite in good. So the pluses and minus sign is what? It's the direction. And the F is the force. It's the magnitude of the force. Very good. And you guys always know from Newton's second law of motion that F equals ma. That's where the second line comes in. F equals ma. So turn to the other side. There's always two sentences in Newton's third law of motion. There's the action and the reaction. I gave you the action, and I want you to write in the reaction. So for number one, it says, you push the wall with a force of minus 200 newtons. What's the reaction? Close. Yes. So say that louder. Good. The wall pushes you forward with a force of plus 200 newtons. Do you guys want me to do a few more, or do you guys just want to work in groups now and do this? Groups. Okay, so everybody has a partner. So I want to hear a lot of talking about physics. So just get in groups of two and talk about, and just complete this together. And afterwards, we can check out work. Could you move with him? Could you move with her? Could you two work together? Yes. Could you move with her? Perfect. You look alone. Pick a group. Yeah. You guys will work together.
So over number two, I think the ground pushes you back. Wait, pushes me up.
Dude, if you fall in your chair after, you're gonna hit that thing.
I'm gonna laugh, but I feel like
That chair I sat on.
You guys should be talking, right?
Oh yeah, you're right.
Wow.
And then a hammer pushes the nail down.
Talk. Yeah, talk to me. Both of you talk to each other. Remember, if you forget, you have this interaction here, you have this interaction here. You're welcome.
Hey,
Okay, man pushes the ground back. If the ground pushes them forward, line pushes them forward.
yeah, I was talking to class.
Is there a group of two that's done?
No, I think it's over. So a rock is no.
All do is down on the nail, and the nail pushes up against it. But I still think it should be
It works, pushes it. Huh? Oh yeah. I think she did. She broke. Social media. Friend did it. Friend did it. She did it. She did. He posted it around 2 girl page. Like that's not fair for other people in that position.
Oh yeah,
that was me.
guys, when you came to each other, maybe this.
The football. I'm so dumb. I don't even know something that last one. Football. So football. No, just bring it.
Go to him and compare your answers. Just make sure that they're the same.
What?
So my face touches your face. So your face.
My car hits your car with a force of 3,000.
Remember, these should be sentences.
Oh wait, I'm sure we ran out. So now.
It's not the worst thing in the world.
Again.
So you like the
No, I'm no.
more sauce.
No, but like everybody is or like before you.
And then
Like 700.
yeah,
So no, how do you understand?
I like that group. Oh, if you really choose like a ability, and then like are they the white ones?
Actually, I mean, we are.
Sorry, pal. I'm just gonna have money.
Minutes in the period.
She told me to like take a picture of you. Are you saying my heart? So you're just kind of like, does he have to like sign off or anything? Where are you
You're still gonna like somebody's right. Are you pretty sure I'm not pointing the world up right now? And then I see
You're the center of gravity. You can't stand straight up. When you bend down, when you bend down, when you stand up straight, you're pushing further back. That's how you get the center.
If you push the.
Pretty sure we only did it.
Everybody have a seat.
Pretty sure just
What? You guys have a seat. So the answers are here, but I'll have each table read one answer. So can you guys read number 2? Okay, did you guys hear that?
Yeah.
Okay. Can you read number 3? Yeah. Yeah, read number 3 up here or from your paper. Doesn't matter.
Okay, the orifice is the fish forward force of
Yeah, I think I made a mistake. The water pushes the fish forward. Very good. Sorry about that. The water the fish, right? I hope you can read that. Any questions about number 3? Could you guys read number 4?
Alright, the nail pushes up on the hammer.
Yeah, the hammer pushes the nail down, and the nail pushes the hammer up. How does the nail push the hammer up? But when I use a hammer, the hammer never goes up. So how is this possible? Okay, what happens to the hammer when it touches the nail?
It slows down.
Say that louder.
It slows down a little.
Yeah, it slows down, right? So what's making it slow down? The nail. When I play baseball and I hit the baseball bat with the baseball, does the baseball bat go backwards?
No.
It slows down. And what makes it slow down? What makes it slow down? The baseball. Good. Okay, so the tires push the road backwards. Somebody say it.
The tire forward.
Now this is something that's a little bit weird, right?
Yeah.
Yeah, because the road is moving, yet it's pushing the tires forward. So this is Newton's third law of motion. You might not get it at first, but just kind of think about it. Are you guys checking your answers?
Yes.
Okay.
Yeah.
Are there any answers that don't make any sense? Question.
15.
15. Okay. When I jump, what does the earth do?
Jump forward.
When I jump, what does the earth do?
Stay.
Pulls you down.
Pulls you down.
The earth pulls me down, right? That's the action. The earth pulls you down. What do I do?
Pull the earth up.
Do you guys agree with that?
Yeah.
I mean, yeah, sorry. Why do you agree with it? Well, I don't see the earth going down. Okay. Let me say this one more time. When I jump, the earth pulls me down. And the reaction is,
When you pull the earth up.
I pull the earth up. But do you see the earth going up?
No.
So how is this possible?
It's under the
The earth
foot.
has too much
It's
air.
literal. Oh, I'm sorry. It's possible. Check it out. You guys remember this equation, right? From page 1. Force of object A on object B is equal to minus force of object B on A. So what is object A? Okay, it's me. What's object B? The earth. And we know F equals M times A. Very good. So let's do the math. So write this down. The force of the earth on the man, is me, is equal to minus the force of the man on the earth. We know F equals m times a. Good. So the mass of the earth times the acceleration of the earth is equal to minus the mass of the man times the acceleration of the man. Yeah, sure. And what are we solving for? Of the acceleration of? Earth. Good. So the acceleration of Earth is, we just solved from the third line. And I just approximated my mass. It's about 8 kilograms. The mass of the Earth is about 6 times 10 to the 24 kilograms. It's on that handout. The acceleration of me is what? 9.8. Down, right? Because acceleration is up. Vector, right? So you do the math, it's about 1.33 times 10 to the minus 22 meters per second squared. So what does minus 22 mean? What do you have to do with the decimal point?
Move it over to the
To the left. So it's a big number or small number?
Small.
Really small number because it's minus 22. So even if everybody in the world jumps at the same time, are we going to see the Earth go up? No. Even if we all weighed like 200 kilograms, which is like 440 pounds, and we all jumped at the same time, it wouldn't be noticeable.
Or everyone's jumping in a different direction.
Yeah. Yeah. So the mass of the Earth is just too huge for you to make a difference. Okay. Just let me show you one more thing and I'll wrap this up. Yeah, could you go to the projector? I'm sorry. Oh, no. Oh, sorry.
You guys still writing that?
I got that.
Alright. Here, I'll freeze it and then
So funny. Do you have a question? Maybe it's not legible. You're okay?
didn't I tell you guys that the smarter you get, the worse your handwriting gets?
His handwriting is easier to read than yours.
Yeah.
He's pretty smart.
Thank you. You almost done? This one? 8 times 10 squared, because it's about 80 times 10. So 80 times 10 is about 800. So what is the Yeah, now is the time to ask. Can I tell you guys a nice quote? It might motivate you.
Yeah.
You can make money, but you can't make time.
Oh my god.
And how was time invented?
What does that mean? You can't. You shouldn't waste time, right? You can make money, but you can't make time. So don't waste your time. Then that quote doesn't really apply. Yes.
If you can't make time, then how was time invented?
I guess I don't know. It's just a nice quote. Don't think about it too much. Okay, can we go to the council?
No.
Could you just copy from me?
Hey guys, yeah, we're going to PowerPoint.
Oh, yeah.
Just let me do a quick. Just let me do a quick review of what we learned today. What did we learn today? Newton's third law. You're right. We reviewed Newton's laws, but we did Newton's third law of motion. So just a review. Women push a seat down. What's the reaction? Good. He pushes woman up. How many forces? One. 1 force. How many objects? Two. Always. Good. Fish pushes water back. Good. Both of you are right. Water pushes fish forward. Say that one more time. Oh, I thought somebody had it.
Oh, you just did opposite.
Yeah, like I said, the equation, it might not make any sense, sorry, but when you see the examples, it makes sense. You just switch the sign, and then you just switch the objects, right? Man pushes seat down, seat pushes man up. What did I do? I just switched the objects, switched the sign. Question? No?
No, I was just
You actually answered our question.
Bird pushes air down. Good.
You would say the same thing.
Ladies and gentlemen.
Bat pushes baseball forward. Backwards. Good. Car pushes road backwards. Good. Okay. Rocket pushes gas down. Up. Good. And we're done. Good. So I just want to tell you on the front of page 1, on the bottom, there's a website. This is another review of Newton's 3 laws. There's a lot of examples and there's a lot of practice problems. So if you don't quite understand Newton's 3 laws, go to this website. Are there any questions? We're good to go? Good. Thank you very much for your time. You all have Oh, one more thing. Can I say one more thing? So sorry. Raise your hand if you're thinking about being an engineer when you grow up. If it's an option. Okay. Medical field? Oh. Okay, raise your hand if you want to major in biology or chemistry. Forensic science?
If you want to be a Marine.
Remember, if you go to university, all engineers, all doctors and nurses, all biology majors and chemistry majors need 2 semesters of university physics. So you should learn the physics now, so you can party at the university. If you don't learn the physics now, you're going to study at the university. You rather want to study now, right? Yeah, so whatever Mr. Simpson and your teachers tell you is best to learn now. Because the older you get, the more difficult it is to learn. True? True. Good. Thank you very much, guys.